My name is Erin Harding, and I'm a Sales and Technical Support Representative here at Solinst. And today you're signed in for part 2 of our 3-part webinar series on our pneumatic pumps. Here at Solinst, we have 2 types of pneumatic pumps. We have our bladder pumps and our double valve pumps. And in part 1 of the series, we went through details about each of these specific pumps. Now in part 2, we're going to focus more on the equipment setup and operation. So with that in mind, many of you will know from experience that field sites are very different, constantly changing, and new information is always being gathered and updated. So the goal of this webinar is really to give you a firm understanding of the equipment and information that you're going to need, either before arriving to site or once you arrive on site, so that you can get the sample that you need using the equipment that we have, and certainly in the most efficient way. And so we're going to flip to a slide right now of a dedicated pump setup. So a dedicated setup basically means that the pump is on site permanently and it's only removed at the end of a project or at the end of a specific sampling period. So with that in mind, certainly if that's not a feasible application, we do have portable setups available and we're going to discuss them a little later on. So here you can see our dedicated system. And in order to collect the groundwater sample that you need, you're going to require the following items. You'll need your pump, which you would have selected based on the information you gained in our last webinar. A source of compressed gas to provide the force necessary to operate the pump and to drive your water sample up to surface. A pump controller to regulate the flow of compressed gas, and the tubing and connections used to join all of these parts together. When this system is running, compressed gas will run from the compressed air source into the controller. From there, the compressed gas will travel down the drive tubing, venting out between drives to allow the pump to refill with water. And as this pump is running, your sample will be pushed to surface via the sampling line. So now, let's move on and take a look at one of these systems being set up and run in our training room. So in this video, we're going to take a look at what sampling would be like when arriving to a site where a dedicated 1.66-inch bladder pump is already installed. The pump that you can see here is a demo pump, which has a clear body instead of the standard stainless steel body so that you can see the bladder moving. Please remember that this system setup would be extremely similar no matter which of our pneumatic pumps that you were using. In this scenario, we're using our 12-volt oil-less compressor powered by a deep cycle marine battery connected via the compressor's alligator clips. Pausing on the compressor for a moment, this is the only compressor that we offer here at Solinst. It can operate up to 125 psi and is ideal for applications up to 100 feet below ground surface when using the bladder pump, or 100 feet below water level when using the double valve pump. Alternatively, a portable gas cylinder filled with either air or nitrogen gas could be used. Although the drive gas does not contact the sample, your sampling protocols may specify which drive gas to use. If not specified, your selection may be based simply on availability. However, in general, nitrogen tends to be drier than air and helps to eliminate condensation within the equipment. For each of your field applications, you'll have to choose which option will be best for your particular situation, and some things to consider will include your drive pressure needs, the volume of drive gas that you will require, available power sources on site, safety requirements, and portability. However, before starting, it is always a good practice to ensure that the tank is drained of any accumulated condensation or water, and this can be done by opening the draining valve on the underside of the tank, but just be sure to close it before moving on. The male end of the supply line is connected to the pressure outlet via a quick connect fitting, and the toggle switch is used to turn on the compressor. The pressure gauge will show the current pressure of the tank, and you will need to open the ball valve to allow air to flow into the supply line and to the controller. The female end of the supply line is connected to the air in fitting on the control unit. And at this point, you can remove the well cap and begin connecting the drive line. The male end of the drive line is connected into the air outfitting on the control unit. And the female end of the drive line is connected to the quick connect fitting on the wellhead manifold. The drive line is vented via the quick exhaust, which you can see here. And then lastly, the sample line is connected to the well cap manifold. Now, all of our system components have been connected. It is important to always take a static water level reading prior to sampling. In our video, the pump is already installed, so the water level reading is going to be used to verify that the pump is still submerged, which we can see, and that the static water level is consistent with previous sampling events. If the static water level had changed, we would have to recalculate the drive pressure needed to raise the sample to surface, and we would also have to adjust our drive and our venting times. If a pump were being installed for the very first time, you would want to be sure that it was installed at the desired depth, that all of the sample and drive tubing was correctly connected, and that the pump was properly supported with a support line such as Kevlar cord. Our Model 464 control unit is what you will use to control the supply of compressed gas to your pneumatic pump. It is available in 125 psi and 250 psi versions, which reflects their maximum output pressure. The one being shown here is a 125 psi version, and you can tell this because the pressure gauge has a maximum value of 160 psi. These units are rugged, dependable, suitable for all environments, and they come complete with the drive line and the supply line. Each control unit will have an air-in connection for the supply line, an air-out connection for the drive line, which attaches to the pump, the battery enclosure, which houses 4 AA batteries, which are needed to power the unit, an LCD display screen to view your settings, and the navigational keys needed to move through the LCD. The pressure gauge displays the pumping pressure, which is the pressure that you will need to drive your sample to surface, and it is controlled manually using the manual regulator. In addition to this manual regulator, our electronic control unit also has a manual control button. And these two features give our control unit the very unique ability to operate even when the batteries run out, which can be extremely helpful when your site is remote and you do not have a spare. When the manual control button is pushed in, it'll open a solenoid which allows the compressed gas to be applied to the pump. And when this button is released, it allows the unit to vent. The LCD display screen has 4 main menus. The About menu will display basic information about your specific controller. And the LCD contrast menu allows you to adjust the contrast of the screen to suit your field lighting conditions. The preset flow rates menu contains 3 predefined drive and vent times for low, medium, and high flow sampling. These cannot be edited or changed. And as we mentioned before, all sites are different, so you may have to go into the user flow rates menu and set up your own well-specific settings. When you arrive on site, you can either create a new sample setting or you can use a saved setting. You can navigate the saved setting menu with the navigational keys until you find your site. And in this demonstration, we're going to use our indoor test setting. When creating or editing your settings, the data input will be the same. You will need a site ID, a drive time in seconds, and a vent time as well. You'll also need to input your pressure. However, this is just a reminder because you must remember to manually set the pressure using the regulator dial. So let's begin sampling. On the left side of your screen, you can see the controller cycling through the drive and vent times, and it will continue to do this until your sampling is complete. In the center of the screen, you can see that the bladder is being squeezed very gently during the drive cycle and then refilling nice and slowly during the vent cycle. And finally, on the right-hand side of the screen, you can see that the slow and gentle rate of your sample collection. This is a low flow pump which produces excellent quality samples by reducing turbulence and air bubbles, which makes it ideal for VOC sampling. Now let's take a quick look at how the system would change if we were using a portable system instead. You can see that the majority of the equipment remains the same. However, we no longer have our on-site pump, tubing, or well-cap manifold. This will have to be brought to site, the pump and the tubing, and it can be done so conveniently on our portable reel, which we discussed in our first webinar. Once the pump is lowered into place, the drive line can be connected to the reel via the quick connect fitting, which you just saw. After that, the sample line can be attached via its push fitting, and then you are once again ready to sample. Hopefully by now you have a better appreciation of how simple and easy it is to physically set up our pneumatic pumps. However, you may still be wondering about the types of calculations needed to collect your sample. When starting the calculation process, you will need some basic information. You may have the information with you in the office, or you may need to gather it at site and do your calculations there. Either way, it's all very straightforward. There are 4 main variables that you will need to calculate in order to select the best equipment for your site and to run your system efficiently. And these include your drive gas, which is the pressure needed to run your pump and push your sample to surface, your drive time, as well as your vent time, and then the volume of drive gas that you will need. One thing to always remember is although both the bladder pump and double valve pump share similar system setups and exterior looks, the bladder pumps and double valve pumps have very different internal mechanisms, and we've tried to highlight that on the picture on the left. These mechanisms and the resulting operating principles were discussed in webinar number 1, and they can be reviewed on our YouTube channel if you go there and you just look up our bladder pump video and our double valve pump video. So with that in mind, for this webinar, just keep in mind that the differences in these 2 pumps result in calculation differences between the 2 of them. We will begin by taking a look at our pressure calculations. First, we'll go through the bladder pump and then the double valve pump. The pressure calculation is a key component in determining which equipment is going to be required at your site. Specifically, it will determine which electronic control unit you will need, either our 125 or our 250 psi option, and it may also narrow down your compressed gas options. For the bladder pump, you will need to know the depth of your pump intake relative to ground surface. And I would like to draw your attention to this, as this will be a key difference between the bladder pump and the double valve pump, both in terms of calculations and deeper sampling applications. The equation itself is very simple. The pressure that you will need is equal to your intake depth multiplied by 0.43 psi per foot, with 10 psi added to account for line loss. So at a depth of 400 feet, we would need 184 psi of pressure to sample using a bladder pump. In this scenario, we would have to use our 250 psi control unit, as the 125 psi option would not be sufficient. And in addition, our oilless compressor would not have enough power to lift our sample to surface, and we would have to source a larger compressor or a compressed air cylinder. Our bladder pump systems do have limitations. They are not designed to operate with pressures exceeding 250 psi, which means for the bladder pump, the maximum sampling depth is 500 feet or 150 meters below ground surface. However, in part 3 of this webinar series, we are going to discuss how this maximum sampling depth can be increased using our drop tube assembly. For the double valve pump, you will need to know the depth to your static water level, which is very different than the pump intake depth variable we needed when performing these calculations for the bladder pump. Again, the equation needed to calculate your drive pressure need is very simple. Drive pressure is equal to your depth to water multiplied by 0.43 psi per foot. And as before, you must add that 10 psi to account for line loss. So in this scenario, which is identical to the one we looked at for the bladder pump, you will only need 32 psi to run your pump and drive your sample to surface. This lower pressure requirement can have many benefits, including the fact that we can now use our 125 psi controller and our oilless compressor. Like our bladder pump system, our double valve pump also has limitations. They are not designed to operate with pressures exceeding 250 psi, which means for the double valve pump, the maximum sampling depth is 500 feet or 150 meters below water level. The next piece of critical information that you will need to determine will be your drive times and your vent times. This is not something that you will be able to calculate in advance. It is something that you will have to determine once you have your pump installed at your site. Once all your equipment is set up, you will need to submerge your sample discharge line into a clear container of water. You will then want to press the manual control button on your controller while keeping an eye on that submerged sample line. You will need to track how long it takes for the bubbles to stop. So when the manual control button is pushed, it begins a drive cycle, which causes that bladder to slowly squeeze and raise your sample to surface. However, for the first several squeezes, it is the sample line air which is going to be seen at surface. So when the bubbles stop, it means that the bladder is fully compressed and that it is the end of your drive time. The bladder pump vent time is going to be based on your pump intake. When the intake of the bladder pump is shallower than 100 feet, you'll want to set your vent time twice as long as your drive time. And when your pump intake is deeper than 100 feet, the vent time will be closer to 3 to 4 times the drive time. For deeper applications, you may need to adjust the vent time to achieve the ideal flow rate for your sampling needs. So now let's take a look at the double valve pump drive times. To calculate the drive time on a double valve pump, you will again need to set up all of your equipment and have your pump intake installed to the desired depth. Next, you'll want to place your sample discharge line into a collection container. You will then press that manual control button again while keeping an eye on that sample line. You will need to track the number of seconds until you stop seeing water discharge and gas starts to be expelled from the tubing instead. This time period is the maximum drive time needed to completely empty the double valve pump assembly. The drive time is equal to about 40% of this evacuation time, and you might be asking why 40%? And generally speaking, half of that total time was used to empty the driveline tube, and then the other half of that time was used to empty the sample line. As a factor of safety, 40% of the total time should be enough to ensure that the drive gas does not enter the pump. However, it should be noted that this calculation is based on well recharge being capable of keeping up with the sample discharge. And if you notice drive gas within your sample discharge, you will have to shorten your drive times. The double valve pump vent time is very site specific and is going to be based on the recharge rate of the well. You can officially calculate your vent time by using a water level meter to monitor and time your static water recovery. Alternatively, you may be able to calculate your well drawdown per drive, as it may be negligible. And to do this, you're going to need to know your well volumes, your sample line volume, and your required sample volume. So finally, let's discuss how to choose your drive gas. Your first option is an oilless compressor. We offer a single stage 125 PSI option for purchase. However, they are also widely available for rent. If you require a higher drive pressure, you may have to seek out a dual stage 300 PSI compressor. However, these have a higher cost and are less available. One thing to remember when sourcing an air compressor is that when you are sampling at deeper depths, your compressor will need to be able to output 3 to 5 cubic feet per minute of air. Your second drive gas option is to source a cylinder of compressed gas, such as nitrogen or air, and these tend to be very portable and also have the advantage of not requiring a power source. However, before you source a cylinder, it is important to have an idea of the volume of gas that you will require to push your sample to surface. In general, you should allow for 10 liters of gas to push 1 liter of water. And the volume of water that you will be required to raise to surface will likely be the sum of your purge volume, sample volume, and sample tubing volume. And with that, we are finished our calculations. So thank you so much and have a great day.